Hi guys, welcome back. So it's finally time that we look at this integral. So we're integrating the square root of tan x. Now a few weeks ago I hinted on my Instagram that I would eventually get round to solving this and making a video for you all. So it's finally time. We're going to tackle the monster, and this is widely regarded as one of the most difficult integral questions there is. Now I've written down the integral. So it's the square root of tan x dx, and I've also written down some tools which we're going to need to help us. The first tool we're going to need to be very familiar with is how to integrate by substituting. Now this involves making a switch of variables to make our lives a little bit easier, and we're going to do this probably 2 or 3 times in this integral, so we need to be aware of how to do that. Tool number 2, the Pythagorean Identities. Now I recently made a video on this, and it involves manipulating the identity sine squared plus cosine squared equals 1, and we get these new identities. So if you haven't seen that, go and check that out first. The link will be in the description for that. Tool number 3, we need to know how to integrate using partial fractions, and again I recently made a video on this. This involves changing the denominator into something linear, so we can use the natural log function. So again, go check that video out. And finally, tool number 4. We need to know and understand this result. So it says the integral of 1 over x squared plus a squared dx, where a is a constant, is 1 over a tan inverse x over a plus c. And don't forget that plus c. So if you are going to try this at home, then now would be the perfect time to do so. I will warn you, it's very difficult, and some of the tricks that I'm going to use in this video are really good and will help you with any future difficult integrals. Right, let's get started. So the first thing we're going to do, I'm just going to write it out again. We're going to start off straight away with a substitution. Note this is an indefinite integral, so we're going to have a plus c at the end, but that's fine. So for our first substitution, let u equals the square root of tan x. Right, and as always when doing substitution, we need to find what dx is, so we can change it. Right, then we can note that u squared equals tan x, and so when we differentiate, we get 2u du equals sec squared x dx. Right, and that's just a standard derivative there. The derivative of tan x with respect to x is sec squared x, so I'll write that down here. So hopefully you're familiar with that. Right, and from this we can now see that dx equals 2u du over sec squared x. Good. But now our term for dx still has something involving x in it, so we need to fix that. Okay, so how are we going to fix that? Well, this is where knowing the Pythagorean identities comes in handy. We know that 1 plus tan squared x equals sec squared x. Right, so this tells us that sec squared x equals 1 plus, and if u squared is tan x, then u to the 4 is tan squared x. So I'll just write that here. U to the 4 is tan squared x. So now we can rewrite our dx as follows. So dx equals 2u du over 1 plus u to the 4. Great, so now we can rewrite our original integral. Okay, so rewriting, we get square root of tan x dx equals, well, square root of tan x was just u, and dx is now 2u times 1 plus u to the 4 du. And we can tidy this up a little bit. So it's going to be 2u squared on the top and 1 plus u to the 4 on the bottom. Fantastic, so we're making good progress. Right, our first real little trick that's not seemingly obvious is that we're going to divide both sides by u squared. So I'll write that. divide both sides by u squared. So what's this going to give us? Well, we're going to get the integral of 2u squared over 1 plus u to the 4 du equals, well, 2u squared over u squared is 2, and 1 plus u to the 4, well, 1 over u squared is 1 over u squared, and u to the 4 over u squared is just u squared. And this is the integral. Good. Now, this is one of them tricks that's not really obvious why you do it until you get the result. So let me quickly point out here that I didn't just look at this integral and solve it. You know, this is a well-known integral and the solution is also very well known. But the important thing is that you pick up tricks like this. So if you're ever stuck with a seemingly impossible integral, you can try these tricks and see if it works. Right, another trick we often do as mathematicians is we just add 0. So add 0. But we do this in a clever way. So we do this by adding and subtracting. So in this case, we're going to do 1 over u squared. And you'll see why this helps us out in a second. So let's do this. So we get the integral of 2 over 1 over u squared plus u squared du equals the integral of 2 plus 1 over u squared minus 1 over u squared over 1 over u squared plus u squared du. Right, and it's easy to see that these integrals are the same. These two terms here cancel out. Right, and why have we done this? Well, our plan really is to separate this into two more manageable integrals. We know that 2 is 1 plus 1, so this is what we can do. We can change this into 1 plus 1 over u squared plus 1 minus 1 over u squared all over 1 over u squared plus u squared du. Okay, so we're looking good, and now we can separate the integral as follows. So we get one integral that looks like this. So it's 1 plus 1 over u squared over 1 over u squared plus u squared. And then our second term is 1 minus 1 over u squared over 1 over u squared plus u squared du. Okay, good. So we've separated them into two fractions. We will shortly separate them into two integrals. So what can we do now? So another common trick when solving these is to look if we can get something in completed square form. So let's have a look at, so just off to the side here, let's have a look at the quantity 1 over u squared plus u squared. Well, it looks a lot like u plus 1 over u squared. Let's have a look what this equals. Well, it's u squared plus 1 over u squared, and we've got two lots of u times 1 over u. So this is u squared plus 1 over u squared plus 2. So therefore, we can say that u plus 1 over u squared minus 2 equals our denominator. And similarly, let's have a look at the quantity u minus 1 over u squared. Well, this gives us u squared plus 1 over u squared. The minuses make a positive. And then we've got minus 2 lots of u times 1 over u. So this time we get u squared plus 1 over u squared minus 2. And therefore we can see that another way to express our denominator is u minus 1 over u squared plus 2. So we get the same thing on the right hand side. Now, how has this helped us? Well, you might be able to see that our denominator is going to be of the form a squared plus x squared now, and hopefully you might be able to see where we're going with that. So let's now rewrite our integral in terms of what we found with the completed square. So I'll write this as completed square, and this is a really useful trick because integrals can often be handled easier if there's some kind of square term. Right, so we've now got 1 plus 1 over u squared over 1 over u squared plus u squared, and 1 minus 1 over u squared over 1 over u squared plus u squared du. And now let's change our denominators into what we found with completed square. So for the 1 plus 1 over u squared term, it's going to make sense to use the negative square or negative completed square form, and you'll see why shortly. Similarly, for the negative numerator term, it's going to make sense to use the positive completed square form. And I hope I'm not just talking gibberish, but in my head I know what I'm talking about. Hopefully it's coming across to you. So this is where we're at now. And now, as I said a few minutes ago, we can finally split this into two integrals. This is going to be helpful for later. So 1 plus 1 over u squared over u minus 1 over u squared plus 2 du plus, and it's the integral 1 minus 1 over u squared over u plus 1 over u squared minus 2 this time. So we now have two integrals. So I'm going to call these I1 and I2, just so we can deal with them separately. So let's have a look at the first integral on its own. So it's 1 plus 1 over u squared over u minus 1 over u all squared plus 2. And once again, we're going to make a substitution. So let a equals u minus 1 over u. And you'll shortly see why we have the numerator with the positive and the denominator with the negative. Because when we differentiate this, so dA by du, we get 1 plus 1 over u squared. So hopefully you can see what's happening. And this tells us that, well, du equals dA over 1 plus 1 over u squared. Great, and now we can rewrite our integral. So therefore I1 equals, so let's just leave the top as it is for now, 1 plus 1 over u squared. Remember, a is u minus 1 over u, so this just becomes a squared, plus 2, and we've still got this du term. So du is dA over 1 plus 1 over u squared. And this is where the magic happens. So this cancels with this, and we are left with dA over a squared plus 2. Right, fantastic. So this is where we currently are, and we are now in a position to solve the first integral and actually get an answer. So this is equal to a squared, and we want it in the form something squared. Well, it's just the square root of 2 squared. Now, I can't remember which number it was up at the top. It was either 3 or 4. In a previous video, we've proved this result, and because we've proved this, we know that it's true. It's of the form x squared plus a squared, so root 2 is our constant in this case, so it's 1 over root 2 tan inverse a over root 2. Right, good. But don't forget that a was substituted. So remember, a was u minus 1 over u. So this is 1 over square root 2 tan inverse u minus 1 over u over root 2. But again, remember that u, right at the very beginning, which seems like quite a long time ago now, but hopefully you're still following along. Remember that u was square root of tan x. So this is equal to 1 over root 2 tan inverse of, well, square root of tan x is u minus 1 over square root of tan x. And there are ways to simplify this, but I'm not too fussed about that for now. And there we go. We have solved our first integral in terms of our original function, square root of tan x. So we're good to go on that one. Okay, great. And you were probably all screaming at me there because I did forget the plus c. So apologies for that, but yeah. Now I've sorted that. Right. So I think that was the hard part done. Moving on to I2, or integral 2. So this was the other way around, so it's 1 minus 1 over u squared over u plus 1 over u squared minus 2. Okay, we're going to do a similar thing. We're going to make a substitution and then see what happens. We're going to say let b equal u plus 1 over u. Right, and again, when we do db by du, so differentiate b with respect to u, we get u, we get 1 minus 1 over u squared. Okay, so this tells us that du equals db over 1 minus 1 over u squared. Right, now we can directly transform our integral. So I2 equals, well, let's keep the top as it is, so 1 minus 1 over u squared. U plus 1 over u, well, that's just b by our substitution, so it's b squared, and we've got a minus 2. Now we've got the du term, which, as we've just shown, is db divided by 1 minus 1 over u squared. And again, a similar thing has happened. The numerator here and the denominator here cancel out, so we are left with the integral of db over b squared minus 2. Great. Right, now one thing you can hopefully see with the denominator now is that we have a difference of two squares going on. So difference of two squares, so b squared minus 2, well, this just equals b plus the square root of 2 times b minus the square root of 2. So again, another common trick in integrals, transforming using the difference of two squares method. So our integral I2 becomes, well, it's db still, and I know some people don't like writing db on the top, they prefer having it to the side, but with me it doesn't really matter. So db divided by b plus the square root of 2 times b minus the square root of 2. Now, if you're experienced with integrals, the alarm bells should be ringing now. This is a partial fractions. So I think this was number 4 or 5, I can't really remember, from the beginning of the video. This is a partial fractions situation. So I'm going to whiz through this without much explanation, because once you've seen how to do, or once you know how to do one example of partial fractions, you can do this to all of them. So basically what we want to do is write the fraction 1 over b plus the square root of 2, 1 over b minus the square root of 2, as sum a over our first term, b plus the square root of 2, plus b over the second term, b minus the square root of 2. So now, what we need to do is cross multiply, and by this I mean clear the denominators. Right, and we get 1 is equivalent to a lots of b minus the square root of 2 plus b lots of little b plus the square root of 2. And apologies if the big b's and the little b's are confusing, but I think it actually makes more sense doing it that way. Right, and now our plan is to eliminate a and b. Well, eliminate a or b to get the other. So let's let b equals the square root of 2. Then we get 1 is equivalent to, well, the a is going to cancel out because root 2 minus root 2 is 0. So we get b lots of 2 root 2. And this tells us that b is 1 over 2 root 2. Okay, similarly, let's let b equal minus the square root of 2. Then we're going to get 1 is equal to a times minus the square root of 2, which tells us that a equals minus 1 over 2 root 2. So now we can rewrite our integral in terms of partial fractions, so let's do it. So we had the integral of db over b squared minus 2, And remember, we wrote this as a difference of two squares. So it's b plus the square root of 2 times b minus the square root of 2. And now using our partial fraction decomposition, we can write this as, okay, so a is minus 1 over 2 root 2. So it's minus 1 over 2 root 2, b plus the square root of 2. And then b was 1 over 2 root 2. 1 over 2 root 2, b minus the square root of 2. Let's put brackets around all of that, and db. Okay, cool, we're almost there. Now we know how to integrate functions of this form. This just becomes minus 1 over 2 root 2 times the natural log of absolute value of b plus the square root of 2. And then for this second bit, we have plus 1 over 2 root 2, natural log b minus the square root of 2. And again, this time I'm not going to forget the plus c. Right, so what was b? So if you remember, b was u plus 1 over u. So our integral becomes minus 1 over 2 root 2, natural log u plus 1 over u plus root 2, plus 1 over 2 root 2, natural log u plus 1 over u minus root 2, and plus c. Okay, and what was u? U was just the square root of tan x. Now we're going back to the very start for that. So we get I2 equals minus 1 over 2 root 2, natural log square root of tan x plus 1 over the square root of tan x plus square root of 2. And then I'll write it down here, plus 1 over 2 root 2, natural log square root of tan x plus 1 over the square root of tan x minus root 2. And don't forget that plus c. So we've solved I2. Absolutely fantastic. So now all we've got to do is put these together. Okay, fantastic. So this is I1, and this is I2, and at long last, let's write them out, because clearly I have nothing better to do at this point. So the integral of square root of tan x is 1 over the square root of 2 tan inverse, here we go, root tan x minus 1 over the root tan x. And again, I know you can simplify this using cotangent and so on, but that's fine. And I know you can simplify the logs as well, but I like to keep it as it is. What I will do, however, is write the positive one first. So 1 over 2 root 2, natural log square root tan x plus 1 over the square root tan x minus root 2. And finally, minus 1 over 2 root 2, natural log square root of tan x plus 1 over the square root of tan x plus the square root of 2, and don't forget that plus c right at the end. So guys, we've done it. It took a while, but we finally got there. This is how you integrate the square root of tan x. I really hope you've enjoyed if you're still watching. I think this video deserves a big like and maybe a comment, why not? If you haven't hit the subscribe button, do so, as I will bring more fun videos like this one. So cheers for watching guys, see you next time.